All right, 1.9, graph and solve quadratic inequalities. Good news. Everything that we are about to do on here, you have already done. You've shaded graphs, inequalities. You've completed the square only on one side where you have to add and subtract the same thing on the same side. You've had to do vertex form where you found the vertex, plotted it, then found your guide points. So you've done everything. It's just putting things together. You're going to need to know a little bit from vertex form and graphing vertex form to completing the square. So we're going to put it all together. All right, there are different ways that you can do this. Use standard form. You can find negative b over 2a. There's so many things you can do. But I will tell you that in my opinion, this is purely my opinion, vertex form is going to be the easiest because it gives you your vertex. It's very easy to plug numbers into it. And if you make everything in vertex form, you don't have to remember a lot. All right, so we're going to graph x squared plus 3x minus 4. Step 1 is to write the original equation. Y is greater than x squared plus 3x minus 4. All right, then what you're going to do is you are going to basically complete the square, okay, which this is that one where because it's y is greater than, you can't do anything to this side of the problem, so you're going to add, subtract the same thing on the same side. So this is when we bump this over and do that, and remember this is going to become your perfect square trinomial. So you're going to bring down your 3. You're going to divide that by 2, which is 1.5. When you square that, it becomes positive 2.25. Now, because you added it here, you have to subtract it here to keep the equation balanced. So this is now your perfect square trinomial, and that is, and write it in vertex form. So y is 1, x plus 1.5 squared, and then combine these, and that's negative 6.25. Now back up. This is vertex form. So if you remember, the vertex is actually very easy to find in vertex form. Okay, so this is the opposite of the sign. So this is going to be negative 1.5 is going to be part of your vertex. The other point of your vertex is negative 6.25. All right, so you're going to plot that vertex. So you're going to go negative 1.5, 6.25. 1, 2, 3, 4, 5, 6, and it's just a little bit below that. Again, it doesn't have to be perfect. So there's your vertex. Now you need to do 2 guide points. Now, because it opens up or opens down, find a point that's to the right of it or to the left of it. Now, what I'm going to go ahead and do is I'm going to use x is 0. So if I plug this answer in and said that if x equaled 0, what would y be? And you only need to plug it in the right side of the problem. Now, I will tell you, you might want to go up here because if this is wrong, this will also be wrong. So hopefully if you go take your 0 and you plug it into this equation, you can usually figure out, wait a minute, something's wrong because you added, subtracted, did something wrong. It wouldn't make sense on the graph. So let's apply some of the information you know. This is a positive parabola. That means it's opening up. So common sense hopefully would tell you at this point there's no stretch or compression. So visually you should know that your parabola is going to look something like that. So if you were to plug it into this equation and get a negative, like a point that's down here, hopefully from what you know about parabolas, you would go, wait, something's wrong, and you would go back and fix it. So take the 0 and plug it in up here. So you would say 0 squared plus 3 times 0 minus 4. Well, that's 0 plus 0 minus 4, so it would be negative 4. If x is 0, then y would equal negative 4. I'm using this equation. Yes, it's an inequality, but the equal sign doesn't matter. So when x is 0, then y is negative 4. So you have the vertex, and then you also have a guide point. You have 0, negative 4, but remember, because it's a parabola, it's also its reflection. So, and its reflection. So if you were to go plot those points, you're going to plot 0, negative 4, and its reflection, which would be here. Now, just like everything else you've ever done, if it's just greater than or just less than, you would put dotted lines. So this would be a point like that. I will be looking on your test for not only a vertex, but the 2 guide points. So you need to make sure you have them. Okay, you'll lose partial points. All right, now the next, because it's an inequality, you're going to need to shade it. Now it's really simple. Because this is a greater than, that means the shading has to be greater than your vertex. So that means your shading would actually go inside of the parabola. Okay, let's go on to B. Same situation, let's change it to vertex form. So y has to be greater than x squared plus 2x. Bump your negative 8 over, because remember this is going to be your perfect square trinomial here. So bump your negative 8, and then remember you're going to do the opposite of whatever you do here. So you're going to bring down your 2, you're going to complete the square, you're going to divide it by 2, which is 1, and you're going to square it, so plus 1. You're adding 1 here, so you're going to subtract 1 here. This is your perfect square trinomial, so your vertex form would be y equals x plus 1 all squared minus 9. Negative 8 and negative 1 is negative 9. You now have your vertex. So your vertex is the opposite of this and that. Not the opposite. Opposite keep. So your vertex is negative 1, negative 9. So go over your vertex. Negative 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's sitting all the way down here on the bottom. One thing I will tell you, when I give you a graph and I go ahead and put the axes on it, 99.9% of the time, you guys all know I make mistakes, your graph should fit on there. If you have to count by twos, I will let you know. So if you end up with a graph and your vertex is way down here, something's wrong. All right, so we have our vertex. What would be a good x value to choose? I would choose 0. 0 is easy math, and it's to the right of the vertex. Now, could you choose positive 1 or positive 2? Sure. Could you choose negative 2 or negative 3? Sure. But make your life easy. Use an easy number. So if x were to equal 0, again, plug it back into the original equation. So 0 squared plus 2 times 0 minus 8 equals 8. So your guide point is 0, negative 8, and its reflection. Now again, let's think about this a second, okay? Does this guide point make sense? It is a parabola that opens up. So that means if this point is right here, is my parabola here and here, is my parabola going to open up? So if this was my guide points right here, is that parabola going to open up? Yes. Next question I'm going to ask is there a stretch or compression? Because remember, if you have a stretch or compression, it changes how wide or how skinny it is. There is no stretch or compression, so it looks good. So go ahead and graph this. It is just a greater than, so this is going to be a dotted line. Now guys, I'm not concerned about how perfect your parabola is. You know, I'm more concerned with, do you get the concept? Now it's greater than, so here's your vertex. At where on the parabola is everything greater than 0? It would be inside, so above the vertex. And remember, the line of your parabola is a boundary line, so you won't color outside. You're either basically coloring inside the parabola or outside the parabola. So, okay, let's do another one. I just want to make sure you guys get this concept. That's why I'm making sure I give you quite a few of these, okay? All right, here. Now, just real quick, familiarize with what you see. Okay, you have a negative. So what does that tell you? It tells you, okay, the graph is going to open down. Now, there is a little bit of a change with this one. Okay, you need an A value. This one has a reflection. You need to take that out of the equation before you complete your square. So anything that has a lead term, you want to go ahead and divide it out. Unlike completing the square before where you divide everything by it, you want to go ahead and take it out. So you're going to factor out that negative 1 right there. And that's going to give you x squared minus 4x minus 2. So what you want to do, that tells you that it opens down. So now what you want to do is, now this is when you're going to go ahead and you're going to complete the square. So you're going to have x squared minus 4x, give yourself some space, bump your negative 2 over, do the opposites here. So bring down your your negative 4. You're going to divide that by 2. It's going to be negative 2. You're going to square that, which would be positive 4. You added 4 here, so you're going to subtract 4 here. Remember, that's your key right here. That tells you what this factors to. So now you have -1. All that does is tells you it's a reflection. X minus 2, all squared, minus 6. So what do we know? Oops, sorry, Belle. Tells you your vertex is the opposite of this, the same as this. So 2, -6. So there's your vertex. Now you need 2 guide points. Well, let's go ahead and graph this. So 2, oh, you know what? Your graph's going to be 2, -6. Why is this graph wrong? Okay. Oh, we're going to count by 2s. That's what's going on. Sorry. 2, +2, -6. 2, 4, 6. There's your point. Now, you're going to pick a guide point in this problem. Okay? So, guide point, again, what would be a good one? Well, you could use 0, but just keep in mind that the 0 may be way up here, which there's nothing wrong with that. Good one to point would be 1 or 0. For easy purposes, I would always choose 0. Deal with the point. If it's a graph when you choose 0, just pick another one. So, the negative of 0 squared plus 4 times 0, 2. This all ends up being +2. So when x is 0, y is 2, and its reflection. So you're going to graph 0, +2, and its reflection. So this was 2 to the left of the axis of symmetry, 2 to the right of the axis of symmetry. Again, this one here is less than, or it's a less than, so it's a dotted line. Now, this is where we're going to change it up a little bit. Up to this point, it's all been greater than. So you would color inside the parabola, but this one is less than. So this one would actually get shaded out here, would be everything outside the parabola. So you're basically shading inside the parabola or outside the parabola. That's basically what you're looking at. Okay? All right, D. Now we're going to be dealing with a quadratic systems of inequality. The same exact concept, except now you're putting 2 on the same graph. So y is greater than or equal to 2x squared. All right, that one looks weird, but remember, only thing missing is the 0. So it's the same thing as 2x plus 0 squared plus 0. So what do you know? You know your vertex is 0, 0. Now you need some guide points, okay? Well, if my vertex is 0, 0, you obviously can't use 0 for x, so why don't we use +1? Okay, so if x equals 1, so 2 times 1 squared, so then y would be 2. So when x is 1, y is 2, and its reflection. So 1, 2, and its reflection. It's a solid line. Now, this is greater than, so when you shade this one's going to be shaded inside. Now go ahead and do the other one. The other one is y is less than -x squared plus 1. Okay, take out the negative, all right, or this is actually already in vertex form. You can actually turn this one into x squared, -x plus 0 squared plus 1. Now, why did we not take the negative all the way out of it? Because it only affects this x squared term. If there was an x squared plus something before the x, it's a little bit different story. So what do we know? Vertex, 0, 1, okay? Guide point, okay? Well, if my vertex is 0, 1, again, another guide point would be if x equals 1. So y would be less than, again, don't worry about the whole less than, it's actually going to be equals the negative of 1 squared plus 1. -1 plus 1 would be 0. Okay, so when x is 1, y is 0. X is 1, y is 0, and its reflection. Again, make sure I see these guide points on your test. So 1, 0, and its reflection. Again, this one is a less than, so that means it's a dotted parabola, dotted boundary line. All right. So we also want it less than. So you're going to shade inside your graph. I'm going to switch colors on this one. So that's what that would look like. So you have two of them. All right, third one. We actually have all our pieces. So this one would be a completing the square. So you want to go ahead, nothing to factor out in the beginning. So you're going to go ahead and you're going to do y is greater than or equal to x squared minus 2x. Give yourself a space. Remember, that's going to be your perfect square trinomial. Minus 4 and give yourself a space. Bring down negative 2. Divide it by 2, which is negative 1. Then you're going to square that, and you're going to 1 here, and you're going to subtract 1 here. So this now becomes y has to be greater than or equal to x minus 1 all squared minus 5. That's your vertex form. And then because we have to do 2 of them, I'm kind of trying to leave a little space over there. So your vertex is 1, negative 5. So graph that. 1, negative 5. 1, 2, 3, 4, 5. Okay, now pick a guide point. Again, I'm going to use 0. So if x equals 0, you're going to get 0 squared, going back to the original equation, minus 2 times 0 minus 4, which results in negative 4. So when x is 0, you're going to have y equals negative 4 and its reflection. So 0, negative 4, 1, 2, 3, 4, and its reflection. It's a solid line, opens up. Okay, and because it's a greater than, you're going to color inside your parabola. Be patient, we're almost done. Okay, now we're going to do the second one. 2x squared, I'm leaving off the y is less than for space purposes, plus 8x plus 2. You have a lead coefficient and you have a full quadratic. So go ahead and pull that 2 out. That's actually going to be your a term, which means we're going to have a stretch of 2, which means this parabola is going to be a little skinnier. X squared plus 4x, and if you're getting the idea, go ahead and bump it over already. Okay? Plus 2. All right? Bring down b, divide it by 2, square it, add it to both, well, not add it to both sides, sorry. Add it here, subtract it here. Where did I get 2? What am I? I'm losing my mind, sorry. I'm actually thinking ahead, that's what's so funny. Okay. You know what look what I did. See if you guys caught it. That's supposed to be a 1 because I factored out the, I knew something was wrong. There we go. That was my mistake. Sorry. Okay. So perfect square trinomial. So now you have y is less than 2, x plus 2 squared minus 3. All right. Now I want you to be careful here because there is a change. You factored this 2 out at the beginning. Anytime you factor something else out, it's going to change your vertex a little bit. Now, the first one is easy. The vertex is negative 2. Here, opposite of that. Now, because you originally factored this 2 out of the beginning of the problem, you needed to make sure that because you factored it out here, this 2 actually affects this negative 3. So instead of this vertex being negative 2, negative 3, this 2 would have to be multiplied by that. So your vertex is actually negative 2, negative 6. Yeah, that's a little different, I know. All right, so negative 2, negative 6. Move this over. Negative 2, 1, 2, 3, 4, 5, 6, right on the base. Now, what would be a good guide point? Probably a negative 1. So if x equals negative 1, go plug it into the original equation. So 2 times negative 1, this would be the y, you're finding out what your y is going to be, squared plus 8 times negative 1 plus 2. Negative 1 times negative 1 is a positive. 1 times 2 is 2. Minus 8 plus 2, that's negative 6 plus 2, which is negative 4. So when x is negative 1, y is negative 4. And its reflection. So negative 1, negative 4. 1, 2, 3, 4. And its reflection. It is a dotted line. Now, could you have used 0 on this? You could have. All right. And it is greater than, okay? So since the, oh, excuse me, not greater than, less than, this is where the change comes into play a little bit, okay? This one is outside the boundaries of the parabola. So it includes this also. So you're going to overlap. So just like systems, technically you're looking for where the overlap would be. So again, the overlap would be right here. Okay? All right. It's a lot to remember, but luckily everything we've done, you've already done. It's nothing new. So at this point, we have a your turn. I'm going to give you 2 of them. Go ahead and hit pause. Do the first one. When you're ready, hit play. All right. This is just one. So, but the idea is if you get the first one, you should be able to do these. All right. So complete the square. Give yourself something to graph in vertex form. So you have x squared plus 2x. Give yourself space. Minus 6. You're going to bring down the 2. You're going to divide it by 2. You're going to square that. You're going to add it here, and you're going to subtract it here. So now you have your vertex form. Your vertex form is x plus 1 all squared minus 7. So what's your vertex? Your vertex is -1, -7. Guide points, so -1, -7. All right, so -1, 1, 2, 3, 4, 5, 6, 7. Guide point, we could use 0. So when x is 0, what's y going to be? You would do 0 squared plus 2 times 0 minus 6. So when x is 0, y is -6. And its reflection, it is a dotted line, opens up, so our points make sense. It is also greater than, so the shading would be inside your parabola. The next one is a system, so go ahead and do that one. Doing the same thing, you're just graphing them. Be careful, you got a negative there. All right, first one, you have y is greater than or equal to, nothing in the beginning, so you don't need to factor anything out. So you have x squared plus x, bump your 4 over. All right, bring down the 1. Divide it by 2, which is 0.5. You're going to square that, which is 0.25. You're going to add that here, and you're going to here. All right, that's going to factor out to be x plus 0.5 all squared, okay, plus 3.75. So what do we know? Our vertex is -0.5 and positive 3.75. So graph that, -0.5 and positive 3.75. 1, 2, 3.75. All right, pick a guide point. 0 a good guide point? Sure, but here's my opinion. It's so close that it wouldn't give you, it would probably be like right here, so it wouldn't be a good guide point, so I would pick 1. Plug it back into the original equation. So if x equaled 1, you would have 1 squared plus 1 plus 4. 1 plus 1 plus 4 ends up being 6. So your guide points would be 1, 6, and its reflection. So 1 and its reflection. So this is 1.5, so it would be right there. Solid line opening up. It's greater than, so your shading is inside your parabola. Okay. Now go ahead and do the second one, and you would get y is less than, take out the -1, changes your signs through the whole equation. Bump your answer. Was a +1, now it's a -1. Bring down your -4. Divide it by 2, square it, you're going to add it here, and you're going to subtract it here, which gives you -1, x minus 2 all squared, minus 3. So vertex form would be, your vertex, sorry, not vertex form, your vertex would be -2 and -3. So -2 negative 3 is your vertex. So what would be a good guide point for you? Okay, that would be negative 2, negative 3. You want to go ahead and you want to go ahead and pick a point. What would be a good one? I personally, again, you could use 0. That's fine. So 0 squared, the negative of 0 squared, plus 4 times 0 plus 1 would be 1. So when x is 0, y is 1. That would be here and its guide point. So here's your axis of symmetry. So it's 2 to the right there, so 2 to the left here. It is a dotted line. So your graph would go here. Oops. Okay, what's wrong with this? What do we notice? And this is me checking this. All right, what is wrong with this picture? How do I know I'm wrong? Because this is supposed to open down, so my guide points are wrong. Something is wrong. Now, what is wrong? Let's figure it out. Let's go back. I did something wrong, and this is a good learning moment. So we took out a negative. Did I take everything? This is what happens when you do everything in your head, and you probably shouldn't. So we took out a negative. So x squared minus 4x would be minus 1. Bring down the negative 2, square it. Oh, look what I did. I added 4 here, but I only subtracted 2 here. So this would be minus 4 here, which would mean this would be minus 5. See? So my vertex should be negative 2, negative 5, which goes off the graph. It's hard to get both of them on there, so I'm actually going to go, and I know I just said earlier in this video to not do this. I don't like this problem. I did something wrong with this one, and for some reason, I don't know what I did. I'm like having a brain fart here. Negative 2, negative 5. Oh, I just figured out what I did. Okay, remember we were talking about this negative 1? It affects this. Okay, so it's actually positive 5. Sorry about that. Little things I got to remember too. Okay, so if we put a 0 in, you can still use the same problem. So instead of negative 5, it's negative 2, positive 5. 1, 2, 3, 4, 5. There we go. Okay, now things are going to be the same. So we have 0, 1 here, here, and dotted line. Okay, so, and then because it is less than, that means it's inside the parabola. Right. See, we are all guilty of forgetting things. I forget that you had to take the negative 1. It's not that I forgot. I mean, I did forget, but I know you're supposed to do it, so just be very careful. But again, that was actually a perfect example of how you can use information you know to check the problem. All right, there we go. We will help you in class next time I see you.